example number 1, I just want you to remember this formula of the Laplace transform. Okay, so find the Laplace transform of a unit step function, which is u of t, of 1 if t is greater than 0 and 0 if t is less than 0. So this is what it looks like if it's graphed. This means that if t is greater than 0, then it is 1, as you can see here. Now for these two values, 0, we can just cross out this one because it will just equate to 0, right? If we will input 0 to our function, it will just be 0. So let's omit that. Now we will just focus to this one. If t is greater than 0, then u of t is equal to 1. Okay. So from the formula of Laplace transform, which is this one, let us substitute the function u of t, which is equal to 1, right? From this one. So f of t becomes the function, which is u of t, so it became 1. So from this formula, it became the integral of infinity, 0 to infinity, 1, which is the u of t function, then e raised to negative ft from the formula dt. Okay, now from this one, we are going to integrate. So you have to recall your integration. Remember that in integration, we have this formula, integral of eu du is equal to eu plus c. Okay, so we just have to derive the u to get this du. So that's exactly what we're gonna do. So this is our u, right? This is our u. That's e raised to u du. So the exponent is the u. So that's what we're going to derive. So from this one, negative st, we know that the t is the variable, and then the negative s is the constant. So that will just be negative s, which is the variable, times 1, t raised to 1 minus 1. So it will become 0. So negative s times 1 is just negative s. So that's the derivative of the u. Now, since we added negative s inside the integral, we are going to add the reciprocal on the outside the integral. Okay, so I hope you recall your integration. Now let's continue. So negative 1 over s, which is what we've added, multiplied by the integral of this function, which is e raised to negative st, and then the upper limit, which is the infinity, and then the lower limit, which is 0. So these limits are already in the formula. So all we have to do is just combine the two. And then remember that if we have the upper limit and lower limit, we are going to substitute these limits into our variable. And here our variable is t, right? So it became negative e raised to negative s times the infinity over s minus, okay, so that's recalling. So that's just the process whenever we have a limit. Okay, so upper limit, substitute the upper limit minus the lower limit. Okay, that's just the process. So minus the negative e raised to negative s times 0. So this just becomes 1, and this becomes 0, because any number that is raised to infinity is just equal to 0. So that became 0 over s, which is just 0, minus e raised to 0 is just 1. So it became negative 1 over s. Remember that any number raised to 0 is just 1. So negative times negative, we have positive 1 over s. Okay. Next, another example. Find the Laplace transform of f of t is equal to e raised to negative at. Okay, so from our formula again, take note lang that the formula is that the t is constant unless the variable was changed. For example, the variable was, it became x and so on. Okay, so let's substitute our function, which is e raised to negative 80. So we have here f of t was changed into e raised to negative 80 based from our problem, e raised to negative 80, e raised to negative st dt. Now from this one, as you can see, they have the same base. So by loss of exponent, if the same base was multiplied to each other, their exponents will be added, right? Okay, so their exponents here was added, so it became negative 80 minus st. And then this one was factored out. The t was factored out, therefore it became negative t times a plus s. Okay, that's where it came from. Now, since we already have this one, we'll proceed to integration. Okay, so what is the integral of negative t times a plus s? So this one is just the constant. And then the negative t is the only one that is the variable. So it will become a plus s multiplied by negative 1, because the integral, the derivative of variable t is just 1. Therefore, it became negative a plus s only. Okay, so since we have added the negative times quantity a plus s inside the integral, we will add the reciprocal of this one outside. Okay, so there exists a 1 over negative times quantity a plus s outside. Now let's proceed to the limits. We will combine these two, inside and outside. So remember, the integral of this one will become e raised to negative t a plus s, because it already became eu du plus c. Now, so we will just multiply each other. So we have here e raised to negative t times a plus s over negative times quantity a plus s. Okay, so upper limit minus lower limit again. We just have to substitute the upper limit to the variable t. So we have e raised to negative infinity, okay, and so on, minus e raised to negative 0, and so on. Okay, so this one, since it's raised to infinity again, it will be 0. And this one, since it's raised to 1, the numerator will be 1, and then the denominator will remain as negative a plus s. So we have this. So negative times negative, we have 1 over a plus s. So that's our final answer. 1 over a plus s, or 1 over s plus a. Now, all of these are actually already defined in as a Laplace transform of some standard signals. Okay, they are already defined. So we have a whole table of Laplace transform, things like that, and all we have to do is just memorize them. I just showed you the derivation of those Laplace transform table, as well as the usage of the formula of Laplace transform. Okay, so in our next video, we're going to explain the Laplace transform of some standard signals, as well as the properties of Laplace transform.